Welcome. This CPD is about natural aquifer SuDS, produced by Hydro Rock Solutions. The Natural Aquifer SuDS programme comprises 3 episodes. Episode 1 introduces the Natural Aquifer SuDS solution within the context of the fast-changing SuDS landscape, including the growing adoption of greener, more stringent environmental SuDS standards based on international SuDS best practice. Episode 2 examines the key features and benefits of natural aquifer SuDS, providing compelling understanding about what makes it the most cost-effective, most efficient and greenest SuDS solution. Episode 3 looks at industrial sector applicability of natural aquifer SuDS, explores a few of the different natural aquifer SuDS systems, and looks at some real-life examples of uses within projects. Let's begin by looking in more detail at the learning objectives for Episode 1. Firstly, we shall define natural aquifer SuDS, understanding the key properties, how it works, and some of its key benefits. Secondly, we shall look briefly at the Dutch experience. What led them to develop Hydro Rock Aquifer SuDS, and understanding that where the Dutch lead today, global national societies will expect their government, water and construction industries to follow tomorrow. Finally, we examine the changing SuDS landscape towards understanding how international, political and environmental trends are rapidly creating a new reality for UK SuDS, examining the elements comprising international SuDS best practice and learning how to best evaluate and identify an effective SuDS system. Conceived in Holland, natural aquifer SuDS are the result of over a decade of intense development of a highly innovative, totally natural new aquifer material. Created by Rockwool, this new material enables a revolutionary approach towards creating and delivering the most cost-effective, most efficient and greenest SuDS solution. Best SuDS are natural SuDS. Left alone, rainwater in the natural environment freely infiltrates the soil where it falls, percolating down to natural aquifers to eventually find its way to the sea. Extensive man-made impermeable surfaces in the built environment have broken this natural water cycle, with displaced water causing worsening flooding problems as rainfall increases. The revolutionary concept behind natural aquifer SuDS is to exactly mimic nature to rebuild the natural water cycle. Natural underground aquifers typically hold less than 20% water of their cubic volume, whereas natural aquifer SuDS holds 94% water. Natural aquifers are only available where they occur naturally, which is not always where they're most wanted. Natural aquifer SuDS now make it possible to place highly efficient aquifer blocks exactly where they are most needed to buffer stormwater and prevent flooding. Natural aquifer SuDS work exactly like a natural aquifer, but just a little bit better. Aquifer blocks soak up water like a sponge, rapidly absorbing 94% water of its cubic volume. They hold water exactly like an aquifer reservoir, suspending water within the capillaries between fibres, supporting the weight of the water, preventing soil compaction beneath aquifer blocks. Then releasing water exactly like a watering can, through capillary action as soil surrounding aquifer blocks dries, drawing out the water through both the bottom and the sides of the block, helping maintain the soil in an ideal condition, preventing heave, shrinkage and cracking in different weathers. Let's look at the three principal properties of a natural aquifer SuDS system. Firstly, it is totally natural, made from a highly innovative new material produced by Rockwool, comprising 100% basalt rock, which is heated until it is molten and then spun into highly absorbent mineral wool. At the end of their long life, aquifer blocks are readily recyclable, simply being returned to the oven to be remade into insulation material. Secondly, natural aquifer SuDS mimic nature, using man-made aquifers to provide enough aquifer capacity to enable rain to be absorbed into the ground as close as possible to where it falls. Thirdly, the natural aquifer SuDS system is a decentralised solution. Its modular configuration allows the widespread dispersal of water across a wide area, enabling proper on-site management of stormwater and runoff. We're now going to compare the conventional sub-SuDS centralised model with the revolutionary Dutch natural aquifer SuDS dispersed model. The conventional Sump SuDS approach is focused primarily on water quantity, treating rainwater as a problem to be overcome, gathering water from across a site into a single centralised crated sump, comprising a large underground void supported by buried plastic crates from which water is discharged off-site into the sewer system or nearby watercourses. Unfortunately, this breaks the natural water cycle, far removed from how the water flow naturally wishes to behave. It also ignores two other critical elements of the water triangle: maintaining environmental water quality as well as site amenity and biodiversity. By comparison, natural aquifer SuDS treat water as a precious resource, something to be carefully managed on-site through responsible water stewardship, not urgently discharged off-site. Natural aquifer SuDS seek to carefully balance the water triangle, attaching equal significance to handling water quantity, maintaining environmental water quality, as well as improving site amenity and biodiversity. Natural aquifer SuDS absorb and retain water as close as possible to where it falls, enabling rainwater to be retained on-site by dispersing it as widely as possible, minimising and controlling runoff through preventing large volumes of water gathering in a single place. Natural aquifer SuDS forms the cornerstone of a much broader on-site SuDS solution, including things like green roofing, permeable paving, reed beds, ponds, etc., all of which is based upon rebuilding and maintaining the natural water cycle. Suspension of water weight within aquifer blocks prevents soil compaction beneath, uniquely enabling infiltration through the bottom of aquifer blocks as well as all the sides, providing aquifer blocks with the highest infiltration efficiency of any existing SuDS system. Natural aquifer SuDS modular configuration allows the aquifer modules to be dispersed widely across a site, and with aquifer blocks within modules to be spaced apart. This provides much greater side surface area for infiltration and helps prevent supersaturation of soil, ensuring optimal efficiency capillary action is maintained. Infiltration begins immediately water enters aquifer blocks, unlike crated sumps, which only begin infiltrating properly when nearly full. All of this adds up to the dispersed model infiltration rate being up to 600% faster than centralised model Sump SuDS. Natural aquifer SuDS have a great many unique features which provide numerous benefits, which we shall examine in detail in episode 2. But let's have a quick look now at 6 of the primary benefits of natural aquifer SuDS. Fully installed cost is a minimum 20% cheaper over any available alternative SuDS systems. Flooding is prevented through highly efficient buffering of stormwater runoff. It is truly green, made from a totally natural material that is completely recyclable. It efficiently filters road surface runoff, cleaning up particulate matter, chemical pollutants, and metals. Its unique 94% absorption, creating highly effective natural aquifers wherever they are needed. Natural Aquifer SuDS facilitates responsible stewardship of precious rainwater, enabling proper on-site water management techniques. Now we have some broad understanding of the Natural Aquifer SuDS, it's worth exploring a little of what led the Dutch to develop it in the first place. Effective water management is literally a matter of life and death for the Dutch, which has served to make them global leaders. They lead development of new solutions and innovative products, invariably adopted and rapidly becoming mainstream in other countries. Accordingly, the Dutch have already addressed and resolved some of the key problems now facing the UK, such as worsening urban flooding problems from increased rainfall and growing impervious surface areas. Typically, the Dutch have developed a highly innovative and totally new material with its unique natural aquifer properties. They did this by taking a completely new approach to SuDS, seeking a system that mimics nature as closely as possible, with all the characteristics and lessons learned from international SuDS best practice. The Natural Aquifer SuDS system is not just revolutionary in and of itself, it has led to fundamental changes in Dutch water management regulation, such as tax incentivised schemes to disconnect industrial, commercial and domestic roofing from the sewer system. Where the Dutch lead, others inevitably follow. Natural Aquifer SuDS is rapidly being adopted elsewhere within Europe and Asia. The SuDS landscape is about to experience quite rapid and significant changes. Growing societal concern about climate change and the broader environment are prompting political initiatives and regulatory action. Looking towards Holland particularly, Europe in general and elsewhere in the world provides a good indication of what is already en route to the UK. It's very worthwhile our spending a little time looking at those trends, examining their implications and what this likely means for the UK. 3 previously individual growing crises are increasingly being considered in combination, creating the perfect storm for UK SuDS. Climate change is bringing rapidly increasing rainfall. Desperately needed housing construction is significantly increasing runoff from growing impervious surface areas. Ecological concern is increasingly at odds with currently permissible but environmentally questionable SuDS practices, such as off-site discharge of clean rainwater into sewers and burying of plastic crates in the ground. Concern is growing about 3 fundamental issues. Increasing stormwater and uncontrolled runoff are increasing the frequency and severity of flooding. The natural water cycle has become broken, with increasing degradation in soil condition through off-site water discharge. Clean rainwater discharge to sewers is overpowering the system, increasing frequency, duration and volume of foul sewage discharges to rivers and coasts. Current SuDS systems and working practice are increasingly being challenged as not fit for purpose. Many SuDS systems are seen as not really green and not following SuDS best practice. SuDS is being seen as not really working as required. Too many construction projects are being granted exceptions from regulations. Many implemented systems are operationally unreliable. Waste of precious resources through unnecessarily treating rainwater at water plants has broad and high societal cost, financial, energy use, CO2 and other environment emissions. Best practice SuDS will become legally required across the whole of the UK, in England just as it is in Wales and Scotland. Things like a complete ban of off-site discharge of rainfall water from new build sites, which are needed to repair the natural water cycle. Construction approval processes will also prioritise ecological factors, with planning approvals increasingly requiring green SuDS systems to properly manage water on site. There is a growing international awareness about and agreement on the key elements comprising SuDS best practice, including treating water as a precious resource, not just as a problem to be overcome, mimicking closely natural drainage, managing rainfall where it falls, avoiding off-site discharge of any clean water, retaining rainwater on site and carefully managing runoff, keeping water as widely dispersed as possible across the site, not letting it gather in one place where it becomes difficult and expensive to manage. Prioritise natural type solutions, following nature as close as possible using ponds, water gardens and reed beds. Prioritise the use of green materials, using natural products that are fully recyclable. Prioritise long-life operational reliability, SuDS systems that maintain performance to designed installation specification. And finally, prioritising zero or very low maintenance solutions, minimising the risk of future problems and liabilities, such as who is responsible for maintenance and who pays. While using the SuDS best practice is a helpful checklist for potential SuDS systems for prospective projects, there is a very simple but extraordinarily effective methodology for evaluating projects. The PAD or PAD test to see if they are possible, affordable and desirable. Essentially, this is a robust evaluation of whether a project will get off the launch pad and will it fly. First part, is it possible? Is it proven to work properly? And can we implement it for our project? Will it really do what we want it to do? And will it work effectively and efficiently? Second part, is it affordable? What is its full cost across its life cycle? Totally installed direct costs, labour, machinery, tools, spoil. How much will it cost across its lifetime operations? Inspection, maintenance, remediation, repair, replacement and recycling, treatment and disposal. What about undesirable and expensive social costs that might be passed downstream from the project to society or to other companies? Third part, is it desirable? Is it really SuDS best practice? Should we really be doing this from an environmental standpoint? Is it really green? Is it really sustainable, even in the short term? That brings us to the end of episode 1 of our 3-part CPD series on Natural Aquifer SuDS. Let's quickly recap on what we've covered in episode 1. We learned about the highly innovative Dutch Natural Aquifer SuDS system, what it is, how it works, and a few of its principal benefits. We looked at the Dutch experience and what led to the development and implementation of Natural Aquifer SuDS. We examined the changing SuDS landscape, in particular the drivers towards greener and more stringent environmental SuDS standards. Finally, we examined the key elements of international SuDS best practice and familiarised ourselves with the PAD test methodology for evaluating and selecting effective SuDS systems. In episode 2, we shall be examining the key features and benefits of natural aquifer SuDS towards understanding what makes them the most cost-effective, most efficient and greenest SuDS solution. Thank you for participating in this CPD. If you have any questions or would like more information, please send us an email or give us a call